we've talked about loops, and we've talked about sequences, and we've talked about selections. So we know we can now ask questions. We can do a loop. And we started with a little bit of being able to shortcut things, and we put compound conditions together. So we could make an AND statement. So we could say two conditions have to be true. So we're trying to go from the binary that the computer loves all the way a little closer to English language. And so we can build some more complex programs and allow the computer to do a lot of that work for us. And so today we're going to look at something that will hopefully do that also. And so we're looking at, move mouse. So we're looking at the idea of something called modules. So modules are a really great way, and if some of you have done web design, you've had some introduction to this. We don't do it in a lot of other classes, but that idea that we're going to write some kind of a module or a function or a subroutine or a method. There's 100 different names we're going to call these. We're going to write a chunk of code, and that code is going to be reusable. We can use it multiple times. So think about things that you have right now, code in your example. I pick up my phone. I know my phone does some things all the time. So think about the code on my iPhone for me to log in. I have to use my thumb, or I have to type in a password. It doesn't make sense for us to write that code over and over and over again when I can simply create a module, that the unlock module, and other programs can access that module. The system itself can access that module. And so that's what we're looking at, those kinds of reusable types of code structures, that we can use it over and over again. And so not only are we going to create these modules, but we're going to make them usable by other pieces of our code. So we know we're going to call it, in this case, we're going to try to just use the word module. If we want to use that module, it's called calling it. We generally say it's a calling function. So generically, we can call a function. We can call a function as many times as we want to. Unlimited number of times. And that's one of the powerful things that our computer lets us do, is we can write a piece of code and it can execute as many times as we want it to. As people, we don't do that very well. We can't do things an unlimited number of times. If I told everybody to run outside and run around the building, well, once would probably work, maybe twice. But if I said by the 14th time, you guys would probably be tired, not really wanting to run anymore. And Mason just said by the 14th, it'd be the first time and I wouldn't want to run anymore. So the power here is now we can write entire sections of code, and we can run those sections over and over and over again. It also can make our program look a lot cleaner, because our program itself is now going to say, go to the unlock function, and it doesn't have all that code segments in it. And maybe it says, go to the hello section where it tells us information. And so our program itself starts to look a little more streamlined. So, this is not a completely new idea, but it is a newer idea in programming. So if I go back in the 1940s and 50s, and yes, there were computers there, this idea of modularization wasn't really as prevalent as what it is today. Now we're saying, all right, we're going to break things down into these modules. Now, can I have a program that doesn't have a module? Yeah. I can do exactly the same thing without modules. So I don't have to do it. It just makes my life a lot easier. The other thing that makes it easier is if I have multiple people working on a program. And most of the time we do have. We don't have just a single person writing the code. So think about your Macintosh, because I know some of you have them. And that Mac OS X, which is up to what? Captain Coyote, Lion, Flake, whatever it is now. Whatever the latest name is. Do you think one person wrote that? No. And in fact, we know that at least 100 people are programmers at Apple, that is their dedicated task. We look at Apple or at the Microsoft Word. One person doesn't rewrite and maintain that code. There's teams of people. So if we write things in modules, it becomes very easy for those teams to interact because they know that, the Get User ID module, let's grab that one. And we can write things to make life easier. So, that idea of abstraction is a little abstract. There's my pun of the day. So the idea of abstraction. So we don't know necessarily what the input is or what's happening. We don't have to know all the details about that function. So if I'm working at Microsoft, I have a library of modules that I can use. I don't have to know the inner details of each one of those modules. I just know that I have the Get User Input module, and I can use it, and I know what it returns. I don't have to have those details about the inside. And if I think about it from a maintaining code at somebody like Microsoft, that's a great tool because I can go out, use that tool, and somebody is in charge then of maintaining that library. So if they see a problem, maybe it's a security hole, somebody hopefully will catch that and be able to fix it. And they patch the module, not every individual piece of code. So any code that uses that module gets fixed automatically. So even in here, it makes it easier for us to reuse our own work. Because I don't expect every time we write a program in here, you to start from scratch, because there already is existing pieces we know are going to work. Now you may have to modify them, you may have to tweak it, but programmers intrinsically are lazy. We want to do things as easy as possible. We don't want to go out and do things as hard as we can. We want to make our lives easy. We let the computer go through and do repetitions. We don't do it. So that abstraction in here also means I can write my code saying get user input. I don't have to write all the details about how that user input is obtained. It's filtered to make sure it's appropriate. So it really gives us an easy way to do it. And most of the higher level programming languages, so it looks very much like English, allow us to do that. And so we can achieve that abstraction. We don't have to do things over and over again. So even from a programming statement, if you had a module that had 10 lines of code in it, and you're going to call it in multiple places, you're making your program 10 lines shorter each time you do that. And we'll get to where you see one, or a sample of one, and you'll see what we're looking for. So dividing it into pieces is really great. So we can write programs in pieces. We can divide it up. So you might have a project manager that says, you're going to do task A, Empress, you're going to do task B, you're going to do task C. And so we can break it up into those modules. Now, when we do that, they're going to have very strict rules on naming and those kinds of conventions. So we all have to be on the same convention. So, for example, we use all caps for what we're going to call a constant value, those kinds of things. So, we have a couple of other R words in here. So, reusability. So, in other words, once we create a module that works really well. So, if I create a module in here, and it gets a user's input, and it does a really nice job of it. It takes that user's input, and it filters it for any unnecessary content, makes sure that it is appropriate for my needs. So, if I need a numeric value, it actually gets a numeric value. If I need a constant or something else, it can do that. That's what I'm looking at in terms of that value. So I may even have a lot more coding in there. So those of you that are in my cybersecurity class, we've talked about injection attacks. And so my user input module may include pieces to block people from putting in malicious code into a user text box. But I don't need to know about all of that when I write the module and I say, call user input module. So it is reusable. And so the other piece then is once I have that module and I've used it over and over again, it's been tested, it has that reliability. We know it's going to work. So I don't have to worry if I say get user input that something's going to go wrong. We've tested it. We know that it functions. If something goes wrong, we can go, oh, we know that works. Let's scratch that out and see why that didn't work somewhere else. So it's really hard to create a method. No, it's actually really, really easy. So what we're going to talk about is kind of the generic model. Each programming language is going to be slightly different, but they have a lot of commonalities. So we write our programs a little bit differently once we start thinking about in terms of modules. We give it a name. So our modules each have a name. And then the main program gets actually really, really small. And so if I want to think about this, my main program, instead of having all kinds of details, now is going to be just a series of call functions. So call program intro, maybe. Call get input. Send crash plan, or whatever it is we're doing. Our program now is a set of very small steps. So if I go back to the program we wrote last week, where you're dealing with classrooms, we could make each classroom independent, and we could just say, all right, so call program intro. We're still going to use that. That brings up a big banner screen maybe. So get input. Now we might get the input of that classroom. And now, so in a very abstract manner, that's our program in 3 steps. It doesn't have all the pieces, so we're just calling 3 modules for that. So we have a program intro, a printout, and a get input. So we have to work on a couple of pieces in here. So a method or a module has a couple of common pieces. Almost every language uses this. So, and certainly Python does. We look at, it's got 3 steps to it. So it has that header, or sometimes we call it a declaration, that says, this is what my step is. So if I have one of those, and I'm going to create a module, so I have to have a header line. So my header just simply says, module get user So that's my header. Now, sometimes it has other information in there, but for now we can just say, hey, get user input. We've created a module. And maybe that one says input, please input your name. And then oftentimes, so that's our body. So we have an input statement in this case. We could have loops. We could have anything else we want to have in there. And then we have, so we've created the body, and now we have to have a return statement. So return statements give us what information gets sent back from that module to your mainline program. So in this particular case, what would we want to return back to the mainline program? I'm asking for an input statement. I say input your name. Does any of that need to go back to the main program? What about that name we typed in? So maybe we want to say return name, because that would put that name back into our mainline program and we could use it in another function. If I don't have that, it may get stuck in that module and not able to be used and anything done with it. Now, on the other hand, I may have a module called hello or program introduction, and this one just says output in this case, we're just using it to set up some functions and we're putting stuff on the screen, it doesn't need to return anything. And so there's a couple of different ways that programs show that. So sometimes we call it void. Sometimes we just go like this. You think, where have I seen a function like that? Well, you've actually seen them. They're called a void function. Nothing comes back literally then. So if I fire up Excel, how do I get today's date out of Excel? So I have a function and I want to know how many days it is until graduation. What day is graduation? Isn't it the 6th this year? So I can put in a date, May 6, 2018. And probably I should do it this way, just to make life easier. But I want to know what today's date is. So there are actually functions in Excel. So equals now is a function. And the weird thing is, all those functions we used in Excel before, we always had to put things in parentheses. Well, this one doesn't actually take in any values, but I still have to use the open and close parenthesis. And that gives me today's date and time off of that function, equals now. So now I could take those and I could say, well, I want to know this date minus this date tells me that it's 81 days until graduation, right? So how many of you guys are going to celebrate Valentine's Day this week? With your significant other. So you all know what day you started dating, right? If you don't, ask her, she will tell you. In that case over there. So if I put in that date, I could do the same function here, and I could figure out how many days, and you could surprise her on that card, flowers. You did remember flowers, I hope. And you could say, it's been a wonderful 374,000 days, or whatever it is, with you. And you could do a function like that using our now function. And then it would then update every day, and you could see how many days do that. So you could keep a running total. So, but we're looking at that functions. So we're just going to say, in this case, return. I'm just going to leave it blank, not put anything in there. So that module is going to be blank. It's going to do something, but it's not going to need a return of any value. So now I can actually write my program. I've got my modules. I can write my program. So now I could write start. And I'm going to call this one. So I'm going to go hello. So I called hello. And I call it actually 3 times because I want it to print 3 times. And in this case, it's only going to put in hello to our program, but I could have an entire set of content in there. And now I'm going to run the get user. So now I want to run get user. But I'm going to do something a little different with this one. And I'm going to say username equals get user input. So what it's going to do, when I run this program, it's going to spit out hello to our program 3 times. And then it's going to run this module. It says username equals get user input. So it's going to call this function, and we're going to put in our name, and it's going to then set that equal to username. So it's going to assign a value. I don't have direct access, and this is where it's a little weird. I have this name value right up here. I can't just use that one because I don't have access to it. We'll work on that idea of abstraction and how we break that out. But that's an example of a modular program right there. So we could do all kinds of other things down here. So this module input doesn't just have to do this. We could also have an if statement. So if name is equal to Pete, the name is going to equal, and we could change the value from Pete to so we could write a lot of content in there. It's all going to get run when we call this function, and it's going to get assigned into the value of username. So here's a program they wrote that's got all kinds of different modules and pieces, and we can make it a little easier by breaking it down into smaller and smaller pieces. So there are some disadvantages to modularizing things. So in a lot of cases, and I didn't do it here, but this module might be a longer piece of code. So here I started to add in these if statements, and I might have added any loops in there. I might have done all kinds of things. It might be a longer running process than if I just said, in this case, input your name down here. So I need to think about what values I'm using. Is it appropriate? But the advantage then, we can divide that up and reuse stuff a lot easier. So one of the problems anytime we write modules, we don't want to use those magic numbers or magic values. We want to make sure that they work for multiple systems then if I'm going to reuse it. Because I don't want to write a module that I can only use once and that doesn't do what I want to in other places. So how we break this down is really kind of an idea about how do we contribute to what's called functional cohesion. So the more the statements in a method contribute to the same job, we call it the greater the functional cohesion. So they all work very closely together, and the more we can reuse them, and they make that module understandable. So we want to create some simple to use, easy methods in breaking things down. So we try to simplify our life, and we try to make it easy to use. So in this particular case, we want to take items and we want to make our life short and easy. And we'll look at some examples of that. There are some downsides or some things that we need to take into consideration. And that's how we can use each method. So I hinted at it here just a little bit, that idea of scope. How do I use this name? So here I returned a value of name. But I didn't return the variable, I returned what's inside of that variable. And so what gets output here isn't the variable name, but the item that's inside of it. And so that's why I had to use this little construct here where I said username equals get user input. And in fact, I could put anything in here. I could call this ABC. Now, ABC has a problem for me because it's not what we call self-documenting, but it would work. And we run into a lot of programs where they use variables of A, B, X, Y, Z. And we know that we use some of them when we do loops as counters and things, but we try to self-document. So this would work the same way. We get the name, it's stored as ABC. As long as they didn't say Pete, they're going to take that name and pass it back out here. So in this case, username then, if I output that, or I could send it to another module if I needed to, or I could do anything I wanted with it, but I passed only the value, not the variable. If I tried to do this and I just said, well, output ABC, I'm going to get, in almost every programming language, I'm going to get an undefined variable. It's going to say, nope, I don't know what ABC is. ABC is used in this module, but I don't know what it is down here in this main program. So for our point to start with, it seems like that's a disadvantage. But the reality is, this can be an advantage also. So let's take this a little different. I'm going to change this a little bit differently. So let's change that to, please input your student ID. And we'll just leave it as ABC. So this module in the program goes out and says, get users input, and says, I want to find your student ID. And through magic, it's going to then say, ABC is equal to ABC, and we're going to perform some little module, and it's going to take off the first 3 letters of ABC. So in other words, if you put in 1, 2, 3, 4, 5, 6, 7, 8, 9, now ABC is going to be equal to a set of values like XXX, 4, 5, 6, 7, 8, 9. Where would we use those kinds of things? Like Social Security numbers, where I need part of a value, but I don't want the whole thing. Well, in this case, because this information might be semi-private, I don't want the mainline program to be able to output ABC in this case, because ABC might have information I don't want to share. So as long as it's contained in here for security, my Social Security or my student ID can be safe. I can manipulate it, I can use it, but I don't necessarily want it available to the entire program or the entire world. And so that idea of we can only use variables inside of the module, sometimes it leads to a little bit of a pain for us, because it makes us think about how we move that data, but it also gives us some really good security pieces. So when I say this, so when we look at the book and you're reading that, and it says variables are only within that method. So they're only visible and they are only usable in that method. I can't just bring my code down and do something with ABC. ABC is going to say, nope, not going to happen. So that's good, but it's also bad because I have to remember that anything I want to use, I have to output back out of that module. So a variable is local to its method. Now, there are some other ways we can do it, but for the most part, variables are stored only in the method or the program that we're using. When that method ends, those variables are gone. They're not known to other methods, they're not known to other programs, so only that little piece of code right there knows your student ID. We've now changed your student ID to just have the last 5 numbers in it, and we output it, and it's gone. It's done. As soon as that module is done running, it's gone. And so that's a really great security measure that we can use with all of our code. But when we're first starting to code, it becomes a little bit of a problem for us because we have to rethink the way we look at the world a little bit. So we do have a few things that are called global variables. And we use those very, very cautiously. So global variables we declare at the program level, not at the modules. And those global variables we can use for the entire program. So they're similar, but we can declare it for the entire program. But they also can give us some scary things. So we wouldn't want to put, hey, let's get an input for a Social Security number at the program level when we need it inside of a module. So the nice thing is if it's something we do use repeatedly throughout multiple modules, we can get to it and we can use it. So if we declare it at the top of our program, we call it a global variable. So we have a term called encapsulation. So wherever we declare something, it's going to stay within that level of kind of a wrapper, if you want to think about it. So on our code here, this ABC variable is only usable here. It's encapsulated to this module. On the other hand, if I wrote a variable up here at the beginning of my program, so I'm going to declare a number, let's call it global number. And I'm going to say that global number is equal to 567. I can use it up here. So I could access it. So I could say output global number, and it would work. We created it, and it can work within any level. But that's not always a good thing. So sometimes what I run into is students, when they start doing this, are going to say, oh, yep, I'm going to take everything and make it global variables. Well, that works in our limited programming here, but it's not good programming practice because we want to use that abstraction. So here I want to be able to preserve that student ID just to this module. And when that module runs, it takes a user's input, it outputs it, and it's gone. The next time that module runs, it doesn't remember that we typed in 1, 2, 3, 4, 5, 6, 7. It's gone. As soon as that module ceases to exist, it's wiped from memory. So, global variables are known to the entire program. If I declare them in a method, then they are only local to that method. I can only use them in that method. So, it makes it a little harder to deal with. So, the next piece we're going to look at then, so if I want to do something global, it's something I'm going to need in many methods. If I'm going to use it more than once, I'll probably declare it globally, unless it's something that's got a security implication, a name or something like that. So later on, we're going to introduce you to what's called object-oriented programs. And so we're going to take that one little further step forward, but I don't want to scare you yet. There's no reason to be scared. Objects are just big black boxes that we put data into and we get an output. So not only can I take data here and I can output my global number here. So I'm going to delete a few things here really quickly so it looks clean again. So I have, in this case, two modules. I have a global number here. I'm going to create one more. I'm going to back this one up just a little bit so it's a nice, neat little module. So I can also take data and I can send it into a module. Well, that makes sense. If I can take data out of a module and send it to my program, I can take program data and send it to a module. And so we're going to create a new module here. So we're going to create a module called multiply. Can't speak. So we're just going to call it module mult. And multiply is going to take a couple of variables. And so multiply is going to take our global number. So it's going to create a variable in here called total. And it's going to say total is equal to global number times, we'll call him input. All right. So we have a couple of things we're going to deal with here, and we need a return. And we'll return that total back to our mainline program. So now we have a module for get input, but I'm going to change this a little bit. I'm going to leave it as ABC, but I'm going to change this to please input your favorite number, and then have it take ABC, and it's going to return ABC. So now our program declares a number, and we need to get a number from the user. So I'm going to run the get user input function, and I'm just going to use the variable number for right now. So whatever the user inputs here gets assigned to number. Well, now I need to somehow pass that number up to this module so it can tell us a value. So I'm going to say, I'm going to call molt, and I'm going to pass in number. So this value we just got out of our first module, now I'm going to send into multiply. And it's going to return something. So to make sure that I see the difference, I'm going to call that program total. I could use the same variable, but it would look confusing because I can't access that total directly. I'm just getting a value back out. So our program now is three pieces. It's going to get a user input. It's going to take that input, assign it to the value of number. It's then going to send that number to the multiply function and send a value back that we're going to call program total. And so if I output program total, that will equal whatever we sent in. So if our user, let's say our user's favorite number happens to be 1, just because I don't want to multiply in my head this morning. So we start our program. We know that this global number exists everywhere and we can use it. We run the get user input function. Please input your favorite number. I type in a 1. It returns the value 1 back here to number. So my next statement then says program total is going to be equal to this function that we're going to pass in the number 1 to. So I pass in 1 up here. 1 times 567 just luckily happens to be 567. It outputs total into this variable here. We can then output that number. Now, obviously, this is a little silly. Could we do the same thing without using modules? We certainly could. But what if we had an entire function in here that would let you multiply, divide, subtract, had loops and all different kinds of things? We may then start to gain some advantage. Right now, it looks like we've added code, and that's not the intent. It's to show you how we can start breaking some of these things down. So if I'm going to create a method that takes a single value, I can do that pretty easily, and that's what we just did there. It took a single value, so number, and quite frankly, if we wanted to hard code a value in there, I could do that. It would pass in the value 123 into the function molt. Now, we don't like to hard code in numbers, so I'm just using that for an example. So we can create ones that take multiples. We can take ones that take less than that. So if we look at, where is, oh, I forgot to open that. Let me grab my book real quick. Week 1, I thought I had opened that already. Apparently I did not. So we take a look at our book. Scroll all the way down to the end of chapter. So our assignment this week says, well, we're going to create a program that performs arithmetic functions. Oh. And we're going to have variables, and so it gives us some details. So before we quite get to this one, let's look at number 1. So it says, create the logic for a program that calculates and displays the amount of money you would have if you invested $1,000 at 5% interest for 1 year. Create a separate method to do the calculation and return the result to be displayed. So before we even write it as a method, let's do this. Can we write this? Can we write this program without methods? So it says the amount of money you would have if you had $1,000. So let's just call it money. So you're going to declare money equals 1,000. So we declared money. And maybe we just call one interest, so we declare interest. And for right now, we're going to call that 0. And we need one for rate, don't we? And so what is 5% in mathematical terms that our computer is going to like? 0.05. And so our money, our interest, and that rate. And so maybe we need another one for a total. And we're going to set it equal to 0, kind of best practice to start with. So now we have our variables that we think we're going to need. How am I going to calculate what that value might be? So I would think that interest is going to equal money times the rate. Does that seem correct? And then my total then is going to equal money plus interest. And then I'm going to output total. So, really quick program. All it does, it doesn't loop, it doesn't ask for input. All it does is calculate these set values. So, what we want to do now is we need to think about how could we do this same program and make a module that does those calculations. So, if I just said, all right, well, here's my start, there's the values I'm going to declare, and I'm going to put these pieces, I'm going to throw them below the program just so I say that they're a module. And I could even come up and I could say, oh, this is module. So module, so I know what it is, calculate. So now I have a module, but I probably want to pass in a value in there. And so I'm going to leave the money in my main program. And I'm going to do some of the calculations so we have one input and one output. So in other words, when this program runs, so our program isn't going to run all of this. That's gone. Our program is going to make some kind of call to the function. And one thing you might want to look at, when you're writing even this pseudocode, if I do a couple slashes, that tells me that it's just a comment. And as we get more complex programs, those comments become really handy. So I'm going to write something that's going to call a function. And I probably am going to need to pass in something to it. So I'm going to leave a couple of these things in here. And I'm going to put them into our module. So I'm going to put the interest and the interest rate, so we have variables inside of there, into the module. So what I don't have for values, I have an interest of a starting value. I have a rate. But what I don't have is a value for money, right? In my module. And I don't have a return. So hang on just a second. Let me add a couple pieces here. So we're going to return total. So whatever runs in this module happens, it passes back up to total. But maybe I don't want to call it total in both because that's going to confuse me. So maybe I call it total here. And down here I'm going to call it bags o cash. So new variable, we're going to output that. I need to call this module somehow. So it's called calculate. And I need to pass something into it. So what's the variable I need to pass into that module? So down here we have interest rate. We have interest that we're going to use. So interest equals money times rate. What might I need to pass into that? What is it missing in terms of a value that it can't see? Does it know how much money we start with down there in the module? So we have to somehow tell it how much money we're starting with. So I'm going to pass in the value money, but I also am going to get a value back out of that function. So that function takes an input and returns a value. So I also have to change this one. So this says whatever passes through calculate comes back into a function or back into a variable here called bags o cash. And then I'm going to output that variable for bags of cash. So let's see what happens. Let's practice and kind of do that desk audit piece and see what happens. So I have a start. We've set money equal to $1,000. Total is equal to 0. But do I really need total right there? No. Where I need total is down here. So I'm going to declare total. And just for giggles, I'm going to set it equal to 0, so when that function starts. So I have my value of 1,000, so it sends $1,000 into the calculate module. And notice that's not in my mainline program. My mainline program is just this. So it takes in that value in here we're going to call it money. And I have some other variables in here. And so it says interest equals money, so that $1,000 times our rate gets the total then, so it adds the money plus the interest rate and returns that value. So in this case, it should hopefully say, over a year, what's $1,000 times 0.05? 50 bucks? So our total should be 1,050. Because it's going to add interest, it's going to add those two together and return it. So this seems kind of silly. We could have just done that in one program, right? But this module, we can expand on it, and we can also do a couple of other things. So if I also wanted to do all kinds of other things with it, I could do that. So if I wanted to compare it to multiple rates, and I can reuse this module as many times as I wanted to. So what if instead of it runs once, could I create this a loop? So I could say while not EOF. So in other words, while we're still getting some value, input money. And so now, back one. So now, I change the same thing and I run it multiple times. So now I put a while loop in there, and as long as you don't put whatever we used as our Sentinel value, this program's going to take in a value for money, so we don't even need this there, because it's going to get input. It's going to calculate it and output it. We're just going to run that loop over and over and over again. So we don't know how many times this module is going to run. And we could do all kinds of other tricky things where we could ask it different time periods. So we're not always limited to just a single item. So we could also input money years. So what if we had a value called years and we put that in there also? Could we calculate how much our interest would be over a multiple set of years? We could. And so now we're taking in two values here, so money and years. So now we'd have to add to this module, wouldn't we? And is it as easy as just adding this times the number of years? No, because we have that accumulated interest. So it would take a loop down there to calculate that, right? So we could do it with a really simple loop where you looped from here down the number of years, right? And that would work. So we can make these more complicated. This module can get very long and very complicated, but it doesn't have to be. So this gives us flexibility. I can rewrite this function and use it multiple times. And so we could even write this function to do this. So if years equals 1, and then all of those pieces are in that, else output so in this case now our module gets a little bigger. It would still work as long as they put in the year 1, but if they put anything else out, it just outputs help I hate math. So not very useful, but just showing what we can do. So that modules can get very long and very complicated. So modules are really great. They're not horrible. It just takes us rethinking of how do I break things down into smaller pieces and which ones make sense. So the book goes into a lot of other details we'll look at on Thursday of different types of passing. So we're going to look at that. So make sure you've read through the textbook. I know that's horrible. It'll probably make you cry a little bit, but it's 12 pages or something. It's not really very long. So on Thursday, we'll look at this. We'll work on breaking down something very similar to our homework problem. There is also one other piece that has happened in your class that you might want to look at. So, this is Valentine's week. And for some other reasons, I always give, and you'll see it if you're in my other courses, you will see that there is this extra credit discussion board this week. It is only open this week. There are no late extensions, but you can certainly go look at it and participate if you would like to earn some extra credit. And in this class, where there's not a significant number of points, extra credit is really, really good. All right, so I will send out an announcement about that to make sure everybody's aware, but the extra credit is a great option. All right, any questions about modules for today? It's really just breaking down into reusable chunks. So if I think about it from a sport event, think about a set of plays. A set of plays is really a module, and you call individual modules. It's very similar to that. If we think about everything we do in life, when I say, I'm going to go to the grocery store, that's a module, and you do a set number of activities. All right, let's get out of here. Go enjoy the snow. It's going to be 60 degrees tomorrow, and then 30 again. But